Welcome back to STEM Academy Education. Hello dear friends. Today I am going to solve some problems of coordinate geometry. Exercise 7.1, question number 3 to onwards. Write down question number. Question number 3. Determine if the points. Question number 3. Determine if the points 1, 5, 2, 3 and -2, -11 are collinear. Are collinear. Right. Question number 3. Determine if the points 1, 5, 2, 3 and -2, -11 are collinear. For collinear, the condition if 3 points are collinear means suppose A, B and C are 3 points. If these 3 points are collinear means these 3 points are lie in a line where if AB plus BC is equal to AC, then 3 points are collinear. If we consider A is equal 1/1, 5, B coordinate of B is 2, 3, coordinate of C is -2, -11. Then by using distance formula, we have to find AB and also BC and also AC. Then we calculate AB plus BC. If AB plus BC, the value of AB plus BC is equal to AC, then A, B and C are collinear, otherwise not. Write down starts with solution. Let 3 points be. Write down. Let 3 points be A 1, 5, B 2, 3 and C -2, -11 respectively. Suppose consider 3 points A 1, 5, B 2, 3 and C -2, 11. Then we need to find AB by using distance formula. AB, the coordinate of AB 1, 5 and B is coordinate of B is 2, 3. So by using formula x minus x1 the whole square plus y minus y1 the whole square. Write down 1 minus 2 the whole square plus 5 minus 3 the whole square whole square. Then 1 minus 2 minus 1 the whole square plus 5 minus 3 2 the whole square. Write down 1 plus 4 square root of 5. AB is 5. Then find BC. B the coordinate 2, 3, 0, -2, -11. Then BC is -2 minus 2 plus -2 the whole square. Sorry, with -2 -2 the whole square root plus y2 minus y1 3 -11 the whole square. Then -2, sorry, B 2 minus -2 2 plus 2 the whole square plus 3 minus -11 3 minus -11 3 plus 11 the whole square. Then 4 the square 60 plus 3 plus 11 14 the square. 14 the square means 196, right? 196. 196, 16. 212 the square root. Next, we have to find CA or SC. SC. The coordinate of A is 1, 5 and the coordinate of C is -2, -11. The distance between AC is 1 minus 2 whole square plus y minus y1 whole square 5 minus 11 whole square. Then 1 minus 2, 1 plus 2 whole square 3 whole square 9, 5 minus 11 is 5 plus 11 16 the whole square is 190 256 9 plus 256 is 265 the square. Take screenshot. Then okay, SC is 265, square root of 265. Then we have to calculate AB plus BC not equal SC. We observe root 5, the AB, root 5 plus 212 is not equal to square root of 265. Square root of 5 plus square root of 212 is not equal to square root of 265. So AB plus BC not equal SC. So these three lines are not linear, collinear. Text screenshot. Again, question number 4. Check whether 5 minus 2, 6, 4 and 7 minus 2 are vertices of an isosceles triangle. There are 3 points are given, but we have to check these 3 points are the vertices of an isosceles triangle. Suppose 5 minus 2 is a point, 6, 4 is a point, 7 minus 2 is a point, which are the 3 vertices of a triangle. So we need to show these 3 vertices are the, so these 3 vertices or points in an isosceles triangle. Then suppose A is 5 minus 2. Consider, let us assume, but let us consider A is 5 minus 2, B is 6, 4, C point is 7 minus 2. Suppose A, B, C. A is 5 minus 2, B is 6, 4, C is 7 minus 2. We have to check these 3 vertices are the vertices of an isosceles triangle. If ABC is an isosceles triangle, then AB is equal to AC, or AB is equal to BC, or AC is equal to BC. Any two sides of this triangle will be equal if this is will be an isosceles triangle. So we have to find AB, BC and AC, 3 sides of this triangle. Starts with AB. AB 5 minus 6. By using distance formula, find the AB. 5 minus 6 the whole square plus minus 2 minus 4 whole square. The square. Then 5 minus 6 minus 1 the square 1 minus 6 the whole square there 36 plus 36. Then square root of 37. The value of AB. Then BC 6 minus 7 the whole square plus 4 minus minus 2 the whole square. The square. Minus 1 the whole square plus 1. 4 minus minus 2 is plus 6. 6 the whole square is 36. Then BC is also square root of 37. FB and BC are equal in length. But then we have to find SC. SC will be 5 minus 7 the whole square plus minus 2 minus 2 the whole square. Square. Minus 2. 5 minus 7 is minus 2. Minus 2 the whole square is plus 4. Minus 2. Minus minus plus. Plus 2. Minus 2 plus 2 is 0. 4 square root is 2. So, here AB is equal to BC, which is square root of 37. So, if any two sides of a triangle are equal in length, then this triangle is an isosceles triangle. So, now ABC is an isosceles triangle. Why? As AB equal to BC, which is square root of 37. AB and BC are equal in length. So ABC is an isosceles triangle. Textbook, sorry. Question number 5. In a classroom, 4 strands are shifted all the points. So, in this question, it is unable to draw this figure on the whiteboard. So, in this question, will be shown on the screen. Take it. A, B, C, and D. Are 4 strands are shifted A, B, C, and D as shown in the following figure. Champa Chameli walk into the class and after observing for a few minutes, Champa asked Chameli, "Do you think ABCD is a square?" Chameli disagreed. Using distance formula, find which of them is correct, Champa or Chameli. Write down the coordinates of, according to this figure, the coordinates of A will be 3, 4, and the coordinates of B will be 6, 7, the coordinates of C 9, 4, the coordinates of D 6, 1. So these are the coordinates of ABCD according to this graph. Okay. Then we join AB, BC, CD, and D. If ABCD is a square, then its 4 sides are equal. AB, BC, CD, and AD. If 4 sides are equal in a quadrilateral, then is it called a square? May be called a square or not? Why? If 4 sides of a quadrilateral are equal, then it may be a rhombus or a square. For a square, 4 sides with 2 diagonals must be equal in length. Then this quadrilateral considered as a square if four sides with along two diagonals must be equal. Four sides equal and SC and BD will be of equal length. Then ABCD will be called a square, otherwise are not. We have to find AB, BC, CD and AD. At first we have to find four sides, the distance between four sides of this figure, of this quadrilateral. If all are same, then we have to find the two diagonals of this figure. Let us start with AB. The coordinate of AB is 3, 4, B is 6, 7. By using distance formula, 6 minus 3 the square plus 7 minus 4 whole square root. 6 minus 3 is 3 the square 9. 7 minus 4 3 the square is 9. So 18 the square root is 3 root 2. Then BC is the distance between BC 9 minus 6 the whole square plus 4 minus 7 the whole square. 9 minus 6 is 3 the square. 9 4 minus 7 is minus 3 the whole square is also plus 9. Square root of 18 which is also 3 root 2. Then BC, CD. The coordinates of CD 9, 4. D the coordinates of D is 6, 1. So 9 minus 6 the whole square plus 4 minus 1 the whole square root. 9 minus 6 is 9 minus 6 3 the square 9. 4 minus 1 3 the square 9. 18 the square root which is 3 root 2. And also you have to find DA. Coordinate of D is 6, 1. The coordinate of A is 3, 4. The distance between DA is 6 minus 3 the whole square plus 1 minus 4 whole square. 6 minus 3 which is 3 the square is 9. 1 minus 4 is minus 3 the whole square is plus 9. So its value will be square root of 18 which is 3 root 2. AB, BC, CD, DA all are equal in length. If AB, BC, CD and DA are equal in length, is it enough data to satisfy ABCD is a square? No. If AB, CD, BC and DA are equal, along with two diagonals must be equal, then it will be called a square, otherwise or not. Right now, we have to find SC, the diagonal SC. The coordinate of A 3, 4, the coordinate of C is 9, 4. So 9 minus 3 whole square plus 4 minus 4 whole square. 9 minus 3 is 6 the square 36 plus 4 minus 4 0 square 0. 36 the square root 6. We have also find the distance between B and D. BD is the diagonal. Coordinate of D is 6, 1. Coordinate of B is 6, 7. So find the distance between BD. 6 minus 6 the whole square plus 1 minus 7 the whole square root. 6 minus 6 0 the square 0. 1 minus 7 minus 6 the whole square j plus 36. 36 the square root 6. SC and BD are of equal length, and AB, BC, CD and D are of four sides are equal in length. So it is a square. Write down. It can be observed that all sides of this quadrilateral are equal of length, and also the diagonals are of the equal length. Right. So it is a square. Then question number 5. Question number 6. Name the type of a quadrilateral form if any by the following points and give regions of your answer. Question number 6. Write down. There are given 4 points. -1, -2, 1, 0, -1, 2, -3, 0. There are 4 points are given. Name the type of a quadrilateral form if any by the following points and give regions for your answer. Suppose these are the 4 points of a quadrilateral. Take A is equal to -1, -2, B is 1, 0, C is -1, 2, D is -3, 0. Then we have to find AB, BC, CD, DA. AB, BC, CD, DA and 2 diagonals. Similarly, using distance formula, we have to find AB and also BC, CD and DA. If 4 lines are equal and 2 diagonals AC and DD are equal, then it is a square. If 4 sides are equal and AC, BD are unequal, then it is a rhombus. If all sides are unequal length, so it is a simply a quadrilateral, not a specific quadrilateral. It is a simple quadrilateral. Do it work. Do it work. Okay. Question number 7. Question number 7. Find the point on the x-axis which is equidistant from. Find the point on the x-axis which is equidistant from 2, -5 and -2, 9. Suppose here is a point on the x-axis. Point on the x-axis is y is 0, which is equidistant from, suppose A to -5 and B -2, 9. Right. Find the point on the x-axis which is equidistant from. We have to find the point on the x-axis. The point on the x-axis means we have to find the value of x if P is the point which is equidistant from A and also P is equidistant from B. Means FP is equal to BP. FP is equal to BP. Why? No, now P is the point which is equidistant from A and equidistant from B. We have to find the value of x on the x-axis. On the x-axis, the value of x and y will be 0. So write down the point P. Let Px0 be the point on the x-axis. On the x-axis, P is a point on the x-axis. The coordinate of a P will be x0. While on the x-axis, y or ordinate will be 0. Px0 is the point on the x-axis which is equidistant from A to -5 and B -2, 9. If P is equidistant from A and B, then FP is equal to BP. Right down. FP is equal to BP. So find the distance using distance formula. Find the distance between FP. 2 minus x ro whole square plus minus 5 minus 0 ro whole square or square root. Similarly, BP minus 2 minus x ro whole square plus 9 minus 0 ro whole square or square root. Then FP is equal to BP, and if we remove the square roots on both sides, then it will be 2 minus x square minus 5 whole square minus 2 minus x whole square plus 9 the whole square whole square. So 2 minus x whole square, a square plus b square minus 2ab, 4 plus x square minus 2ab minus 4x minus 5 whole square plus 25. Similarly, minus 2 whole square, 4 plus b square x square minus 2ab minus 2 into minus 2 into minus x plus 4x plus 81. Similarly, both sides x square is cancelled. So minus 4x plus 29. Both sides 4 also be cancelled. Plus 4 plus 4. Minus 4x. 4x is transposed to LHS. Plus 4x will be minus 4x. Plus 81. Plus 25 transposed to right hand side, which will be minus 25. Then minus 80x equal to minus 56. So plus 56, x equal to 56 by minus 8 minus 7. So x is minus 7. The required point is, write down, the required point P is minus 7, 0. Minus 7, 0 on the x-axis, which is equidistance from A and B. The coordinate of x-axis is minus 7. Then question number 8. Similar question also given. Question number 8. Find the value of y for which the distance between P 2 minus 3 Q 10 y is 10 units. The distance between P and Q is 10 units. Given P is 2 minus 3 and Q 10 y. For which value of y? For which value of y? PQ is 10 units. So write down PQ is 10 units given. PQ is 10 units. Then we have to find PQ by using distance formula. Write down 10 minus 2 whole square plus y minus 3 whole square root. PQ is 10. Putting the value of PQ 10. 10 minus 2 is 8. 8 whole square is 64 plus y minus 3 is y plus 3 whole square root. Then 64 plus y square plus 9 plus 6y square. Squaring the both sides. 10 the square and 64 plus 9, which is 73, plus y square plus 6y square root whole square. Squaring in both sides. So it will be 73 plus y square plus 6y, which is 100. Then y square plus 6y plus 73 minus 100 equal to 0. Y square plus 6y 73 minus 100 minus 27 equal to 0. By find the value of y by using middle term split or quadratic equation. Write down y square plus 9y minus 3y minus 27 equal to 0. Split the middle term 6y as 9y minus 3y. Y taking common, y plus 9 minus 3 taking common, y minus 9, y plus 9 is equal to 0. So y plus 9 into y minus 3 equal to 0. Y plus 9 is 0 or y minus 3 equal to 0. Y equal to minus 9 or y equal to plus 3. The value of y is minus 9 or